I will be talking about something that all of you know, all of you have used, large language models, but I promise to you I'm going to give you something interesting to look at. Particularly what we will do today is a new framework that I'm calling the framework of discursive networks. And it's going to be very, very useful to leverage the power of these tools for our scientific needs. So let's see. Let me make sure that this mouse is running. And I can go to the next one. So what we will do is we will introduce this concept of discursive networks. All of you have heard about invalidation, right? Just raise your hand if you have heard of invalidation. Okay, that's only one of the possible types of error that occurs, but the community is focused on hallucinations, and we're going to have to reframe that. And then we will show how can this be deployed in an algorithm just by looking structurally at these discursive networks. This has cultural implications, and I'm going to start with reminding you this. It took, let's see, 3,700 years before the spaces between words appeared. 37 centuries of writing before somebody thought, what if we put space between words? Table of contents. 3,000 years of writing before somebody thought, well, maybe we need a table of contents, and so on. I show you this just because we are at a, I still have my hat. We still are at the beginning of a cultural shift, a profound cultural shift. And I will invite you to stop thinking about large language models, particularly large language models, as just another tool. The difference here is that the medium is acting on the message, and we have never had that before. And this is shaping culture very, very fast. We're moving to a new mode of operation. So let's define what this discursive network is. It's not only humans. Now we have computers and a diversity of computers. Not all computers are speaking in this with the same tone, with the same depth, with the same broad type of speech. And this is shaping how ideas circulate. All of you are exposed, or you have heard about disinformation. Disinformation is the intentional spread of false information for political purposes, etc. Much of this is driven by machines, not by humans. And it's now part of the political speech, social speech, in many forms of exchange of information. So to engage LLMs, we're going to use just 3 categories, and particularly we're going to focus on the critique category. Think whatever you want to do with a large language model, whatever you can envision with a large language model is going to fall in one of these 3 categories. Either you're going to do product-oriented generation. For example, you want to write a piece of code, a piece of software, and you know exactly what it needs to do. So you're guiding the machine to produce what you need to produce. You might use it for ideation. You can ask, hey, give me ideas for, and so on. And this is very broad. You don't know what the outcome is going to be because you're not giving a direction, you're just exploring. And then there is the critique. And the critique is the critical space for us. Because if you ask a large language model to generate ideas, it's an open-ended question. But if you give a piece of text or an artifact that is not necessarily text and ask, what are the flaws here? That will give you a lot of performance for very little computational time, because that sits very close to the optimal space of large language models. We talked about hallucinations. That's the word that the community is using in this moment, but hallucination implies a private sensory distortion. And what we're observing with large language models is that there is a public distortion of knowledge. When a large language model produces a fact, that fact can be transformed and replicated, parroted. by the community, and it's affecting the scientific community. It's beyond now the stage of joke that so many manuscripts are being produced with very poor command of the technology, producing very poor results that are useless. Somebody trying to advance the career. Actually, we will talk about one of the improprieties that happen when you use large language models that way. So for us, it's going to be invalidation, because invalidations happen in multiple categories. Hallucination is just one of those. Hallucination, content that is ungrounded in any trusted source. Contradiction, internally inconsistent statements. And I'm sure that if you have engaged large language models, you have seen it. In a chat, the machine might contradict previous statements. Deductive error is the easiest. You can ask for a mathematical proof, and it's guaranteed to have errors. And it's just the way the content is generated. Pragmatic impropriety. Well, impropriety is when the outcome is breaking social norms. You can have Grok with a K praising Hitler, and most of us find that just not acceptable, but the machine is doing it. Format violation, if you have asked for data in, let's say, a JSON format, you will see that not always returns in that way. If you ask for LaTeX code, sometimes it will give you a markdown, or it will combine both of those. So we have a number of categories, and this family could be larger. These are the ones that I could think of. Maybe there are more. So, being a humble mathematician, my job is to create a structure here. And I'm going to create a structure of the objects that I just told you. These discursive networks that are humans and machine exchanging information. And there is a number of definitions here. The structure is the discursive network, but there are so many elements that to remember it, maybe we can come up with a mnemonic, a speak bug. That's the letters in that acronym, in the structure. That's when you speak, there will be a bug. There are always errors when you exchange information. So if you remember a speak bug, then you have all the variables there. Now here, oops. I'm going to use that definition, and I'm going to deploy it in one specific way. I'm going to make certain assumptions about the distribution and the probability distributions of each one of the quantities involved. So here in this case, we have an update rule that is going to follow a Poisson and a binomial distribution. I know that there is an information overload, so I'm not going to stop on the details. I'm just going to mention two things. The error generation of a large language model seems to follow a Poisson distribution because the rate of error generation is more or less constant. And at infinity, we could perhaps determine that it's a constant, but seems to follow a rate that results in a Poisson. The likelihood of detecting an error, you can assume that is following a binomial distribution, that there is a somewhat equal probability of detecting errors in a discursive network. Okay. When we do that, I'm going to go through the definitions. We can ask the question, what happens with true and false statements? All we will do is track the existence of true and false statements. And this is just a Markov process, a very simple probability switch between true, false detection. And what we observe is that there is an asymptotic state. Things stabilize in a network. How does this look? I took a couple of studies, just they had the data in the format that was useful to me, not because they were particularly interesting, although the authors, I'm sure that they considered them to be very interesting. But I just needed to be able to compute some probabilities. And based on that, this is what I computed. The implementation of that Markov model shows that the blue lines are true statements as they stabilize through time, and then the red lines is false statements as they stabilize through time. That is with a single network, single discursive network. One person is generating content with one agent. That agent plus person is one network. What if we add two discursive networks? That is, what if we put two agents working independently, and then you can interact with each agent, and because you're interacting with those agents independently, that's two discursive networks. You could have multiple agents interacting with each other, that becomes one discursive network. The point is that it influences the error detection. And just by increasing the network, the number of networks, we decrease error. So this is a theoretical estimate, not a computed exercise. The theoretical estimate is that for this data, had they used two discursive networks, they would have reduced the errors by half. So here is the interesting result, I believe. Why are we doing this formalization? Because now we can ask a very important question. If I want the content that I'm preparing with a large language model to have certain level of truth content, guaranteed truth content, let's say 5%, how many agents do I need? That's the important question. Because in this moment, I know my colleagues, I know my students, everybody just go and engages with ChatGPT or a single agent, or maybe the more sophisticated engage with a number of agents. But the question that you should always be asking is, how many do I need? Because that will dictate the amount of resources that you have to put on the table, the amount of effort that it will take to achieve something. So using that framework, that's the importance of creating a mathematical model for these things, is that now we can estimate. We can go to the Poisson and binomial distribution, the properties, what happens at the limit, and we can estimate this number. This is gold, because now you can go back and recompute and say, okay, if I use a single network, I am in the space of close to 60% error, which is what was reported. If I use two discursive networks, that is two agents, and there is independent interaction with two agents creating two networks, I decrease the error by more than half. And then there are decreasing gains, and for a computational exercise of 5% of false statements, I would need 9 agents involved. And if you are performing a sophisticated task, you can ask, how many agents do I need to engage to reach the level of truth that I want? By definition, when an emitter sends a message in human language, there will be error, by definition. We can engage in a philosophical conversation, theory of language, but error is implied. What you can do is minimize the amount of error in an exchange of information. This is what we can do. We can set the acceptable level of error. Once we do that, then we can implement. Now, in the material for the workshop, I posted a manuscript. I finished that last week. So it has been now through 4 iterations, and the title has changed. Now the new title is the current title of this session, which is A Mathematical Theory of Discursive Networks. And this keeps evolving, but the version that I posted earlier today that will be available at 8 p.m. Eastern Time, that's when the archive updates the files, that's the one that you want to look at, because it contains the estimation of what we saw before, and a section on the ethics, because there is a problem here. We can operationalize all that I said in an algorithm. And the code is ready. And I'm going to show you what it does. If you go to this repository, foo, for flaws of others, then you will find something like this. So this is an exercise that we did with LaJoyce. Is LaJoyce here? No, she's not here. But I talked to her and I told her that we would show this. We started with a simple question. By the way, this interface has 5 agents here. How do we define these 5 agents? This is a Python program. The instructions to run it, install it, step by step, are in the repository. The Python program looks something like this. It loads the agents. The configuration file is how we define the instructions for the agents, general instructions, and then each one of the agents that we want to engage. So if I have a problem for which I need 9 discursive networks, I would create at least 9 agents, at least 9 agents. I could also put multiple agents in a self-embedded structure, and they would become part of a discursive network on their own. So you could have 3, 4, 5 agents part of a discursive networking. And you get the idea. Here, the interface, because the configuration file has 5 agents, then we load 5 agents here. I just did a test of ideation with LaJoyce. She wanted to talk about senolytics. So the question is, I want to discover new senolytics. Give me ideas. Okay? And this message went to all the agents. Here at the bottom, you can broadcast a message to all the agents. Then this agent called Gabriela gave me some answers. Well, this is the definition of senolytics. It depends on identifying agents that selectively induce death in senescent cells, and so on. But that is insufficient. It's ideation. Once you do ideation, you're going on a fishing expedition. The optimization space is too large. What we have to do is what this button here calls vulnerability. Vulnerability simply takes the response that this agent gave, and it will send it to all the other agents and ask, find the errors in this response. And that's exactly what the other agents did. So everybody answered the same response. I'm going to go to other agent called Gabriel. Gabriel gave his response. And then, let's see, came the question from vulnerability. Agent Gabriela opened herself to the world. The cruel world just went and tried to find all the errors that she had made, and says, Agent Gabriela answered the same question as follows. Find the flaws. So here is the answer that Gabriela gave. And Gabriel says, well, offers an overview, but presents several conceptual and stylistic shortcomings given the requirements for blah, 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 blah. The response fails to specify the intrinsic molecular distinctions among BCL2 family members, such as the, and so on. So, she omitted a few things. Sometimes, I don't know if it did it here, information is wrong and it catches wrong information. Then Agent Claudius. Agent Claudius said the following about Agent Gabriela. This lacks precision. Agent Gabriela states that BCL2 inhibitors trigger apoptosis and so on. However, here is the correct information. So that's just the vulnerability step. Everybody criticized Gabriela, but that is not enough. Now we have a bunch of agents that have criticized a single agent. They're ganging up on her, just saying all the things that she did wrong. Now we have to reconcile all these things. And that's the next step called judgment. For judgment, we have an agent. In this case, I call this agent Hermione, like the character from Harry Potter, the one that is bossy, telling everybody what they need to do. Well, this agent does that. And in the graphic user interface, you see a checkbox here that is the harmonizer. And because it's the harmonizer, you could have multiple harmonizers. Harmonizers take the response from all the agents and compare against the response of the one agent and then try to reconcile. And let's see what Hermione said. She received all the responses from all the agents. So I'm going to go back a little bit. You can see here, Agent Claudius. This is the response of Agent Claudius. This is the response of Agent Gabriel. This is the response of Gabriela. And this is the instruction for Hermione. The following statements are the flaws others found for Agent Gabriela's response. Organize their responses by topic in an additive manner. That is, do not eliminate information. Structure your response using the following sections: agreement, disagreement, and unique observations. This is in the configuration file. You can change these instructions and do whatever you want to do. With those instructions, refine, expand, contract. You can have more constraints here. In unique observations, highlight observations, blah, blah, blah. And here is the information that came from the agents. Let's see what Hermione answered based on this. Agreement. Multiple agents comment that BCL2, let's see, discussion lacks mechanistic details concerning interactions among pro and anti-apoptotic members. I mean, now it's getting interesting. It is really getting interesting because it's telling Gabriela all the things that she needs to improve to make a better answer. Disagreement. None of the agents directly contradict each other on factual grounds. I've been doing this for a while. Many times they contradict each other, and it will be listed and identified here. Unique observations. One agent remarks that the answer omits discussion of off-target effects. One agent highlights that the original explanation references P53 without mentioning P21's role. Well, this is good. One agent specifically corrects the inaccurate statement that, well, blah, blah, blah. I don't understand that part well, but apparently there is a contradiction. Once we do all this, then we go back to Gabriela and we do reflection, is the third button that is here in the interface. And I'm so sorry that this screen is like on night mode perennially. So it's very yellow, you cannot see this well, but there is a button there that says reflection. What is reflection? We give Gabriela all the judgment. And the instructions that Gabriela receives are the following. Let's see, let's go back to the end. Judgment of your responses has resulted in the observations that follow. Regenerate your version of the text on the review, taking into account the consensus of these observations. If you object to an observation, explain why. And here is the collection of observations, and this is the response that Gabriela gave. Now is the refined response. Now she starts adding all the things that were missing before. And it starts to get very interesting. Because the next one would be, now give me a gene regulatory network implemented in MATLAB, for example, or let's start finding references for this study, and let's make sure that those references actually exist. Give me the DOIs and the URLs. And this thing works. It works so well that in January, I submitted my first fully generated AI proposal to the National Science Foundation, and that went through the panel like a hot knife through butter. And I just got the notice of award on Monday, yesterday. So it went through. Another funding agency, I have a proposal that went through second stage, also fully generated with AI. This manuscript that I mentioned, the one that is in the archive, you should take a look because I didn't write directly a single word in that manuscript. But how is that possible? It's possible because I'm engaging the agents. And that's what is the trick. I know that I have 2 minutes, so I'm going to go back to the slides and finish a very interesting consideration, and with that, we will leave it. Creativity lives in the tail of the distribution. Just remember that. If you ask for open-ended questions, you're going to get who knows what. But if you ask for flaws, and that's why the algorithm is called the flaws of others, because apparently there are universal properties of language. In large language models, just like humans, they can see better the flaws in others than the flaws in themselves. We do the same. Ethical challenges. I introduced this concept of epithesis. Epithesis is something that people in linguistics use to characterize the phenomenon when a letter is added to a word, but it doesn't change the sound or the meaning. It happens. What happens when you engage with a large language model? Actually, when you don't engage, you submit a query, copy paste, put it in the email, off it goes, and you never even read what it was there. How many of you have done that? A lot of people have done that with large language models. Well, the moment you do that, you're breaching a contract an ethical contract with yourself. You should not do it. If you do it, that's the bad use of large language models. You need a discursive network for this to be effective. And what is the network? Is a human plus the machine plus maybe other humans. And what is most effective is when these discursive networks cross different knowledge bases. That is the best network is the one in which you have somebody from Anthropic, a few agents. In this case, in the interface that I showed you, Gabriel and Gabriela were GPT, and Claudius and Claudette were Anthropic's Claude, because they were training different data sets, and they will be able to find much more effectively the errors of the others. If you have agents that come from the same knowledge base, if there is an error in the training data set, they will not be able to catch it as effectively. And I've seen this phenomenon. There are things that GPT doesn't catch with multiple agents, but Anthropic does. Reasoning versus outsourcing, all this is connected. We see it in undergraduate and graduate students and even in professional settings. When people stop thinking and just outsource the thinking to the machine. And that is the bad use of this technology. It should be augmented intelligence. That's what AI stands for in my mind, not artificial intelligence. It's augmented intelligence. It's augmenting ours. We're not just augmenting theirs. Resource inequity. What I just showed you in that little loop with the agents is very resource intensive. If I have a single agent producing and everybody criticizing, that grows linearly with the number of agents in computational complexity and therefore in energy expense. If you have every agent checking every other agent, that's n squared. And if you have everybody also harmonizing, then you have now n squared log n. So the number of tokens, if before you were doing 1 million tokens, just do that in your mind. What is 1 million squared log n? You have exploded the amount of energy for engaging with these agents. So there is an ethical question that I know I'm releasing a monster. The monster is this tool. It's ready to use. It's very effective. Of course, people who use it will have to pay for those API keys, and the price will stop many people, but not everybody. Corporations, legal entities might have the ability to spend a lot of money and therefore consume an absurd amount of energy. In this moment, 5% of the electricity in the US goes to data centers. In 10 years, it's going to be 10%. That is going to be more electricity than more than half of the countries of this planet. And it keeps growing, and we will just make it worse with these conclusions. Discursive networks is a very powerful tool because it gives us the ability to create formalisms for understanding the asymptotic behavior and the dynamics of large language models interacting with humans. The concept of invalidation is important. Please stop using hallucinations. Hallucination is just a small, tiny bit, and the community is not paying attention to all the other bad things that are actually happening in the destruction of correct information. The flaws of others algorithm, what I just showed you, it operates near the optimal space for large language models because it's much more common to find these observations of the flaws, the person needs this, and all the negative language. Negative language propagates faster in discursive networks than positive language. And finally, we have entered a new cultural paradigm. This is not writing as we used to do it. This is not authorship as we used to have it. We don't have metrics to do this. We're just creating them right now. And just remember that if it took us 37 centuries just to put the spaces between words, it's not going to take us 137 centuries to figure out what to do with large language models. My point is that we're just beginning, and there are many things that need to be defined. This is not just a technological question. Perhaps that's the most important. Forget about all the software. This is a cultural, ethical question. We're in a different mode of operation that we poorly understand, and it's going to create profound inequities in the world. And with this, I have to advertise that this was half an hour, but if you want to dive deeper into this, come to our program. DARE 3 does not compete with CGSI. It's in a different month. It's May and June. And we receive everybody. We have had from graduate students to deans attending the workshop. This is for professional development supported by the National Institutes of Health. There are 3. Come and talk to me if you're interested. And finally, I'm entering a 1-year sabbatical after being 6 years a chair of a math department, the largest academic unit at my institution. I'm fed up, but I'm very happy that I can do research full-time for the next year. So I'm open for collaboration. So thank you so much for your attention. I apologize for the tardiness of the beginning.